As we move into the month of July, the Hytale team has provided us with a new blog post. The blog post discusses all about Hytale's engine transformation and diving into the magic behind the scenes. Ever wondered how game developers make characters come to life and react intelligently? Well, enjoy today's video as we explore Flex, a cutting-edge component system that is revolutionizing Hytale's performance, modding capabilities, and cross-platform potential. From rebooting the engine to C++ to making NPCs think faster and smarter, discover how this powerful framework is setting new standards in the development of Hytale. Now, without further ado, this is Ani, and let's take a deeper dive into the most recent Hytale update. The Hytale team begins the blog post by saying, "Hello everyone. Today we are getting an inside look at the technology behind Hytale's engine, specifically focusing on Flex, a lightweight and powerful entity component system." Previously, the team decided to reboot the Hytale engine, transitioning from a Java server and C# client to building both in C++. This change was driven by the need to release the game across multiple platforms, improve performance for lower spec devices, and build a robust core engine for future maintenance and updates. They also mention with an image that this blog post is separate from their standard development updates. Maybe this means we could still be getting a development update blog post in the near future? If so, what would you guys like to see in the next blog post? If you are unfamiliar with Entity Component System, or ECS, ECS is one of the key tools helping them achieve these goals. In this post, they discuss why they chose Flex as the ECS foundation for Hytale's new engine, and how it supports their objectives. But before diving into Flex, they explain the ECS pattern itself. They explain it as a traditional game development. The foundation often rests on familiar programming paradigms, like object-oriented programming or entity component architectures. OOP, or object-oriented programming, widely used in software development, organizes systems into manageable objects with defined behaviors and attributes. For instance, a game might have a universal character object type that contains shared game logic, inherited by a specific player and NPC objects to define unique functionalities within the game world. The team then expands on how Entity Component brings the Hytale worldboard to life. They explain that a player might have components for position, controller inputs, and inventory. An NPC also has a position and inventory components, along with behavioral logic. A chair, however, only has a position component, meaning the chair likely won't get up and walk away. They continue by saying that the structure is very flexible for modding. It supports highly data-driven functionality through asset configuration. By changing an NPC or object's components, you can achieve different behaviors without modifying existing code. With a scripting language, you can even create and add your own components to entities, expanding the possibilities of what can be done in the game. So modders, be ready to mod. However, this still isn't ECS. ECS takes the concepts of entity component architecture and advances them further. In the entity component model, functionality resides within the components themselves. However, ECS separates this functionality from data and stated processes. Instead of each component having its own internal update logic, ECS uses systems that match entities with specific sets of components and act on them. Now, you might not know exactly what this means, so let me try to sum it up for you. This means ECS allows us to compose entities from various components, but the separation of data and logic makes it significantly more efficient for hardware to run, enhancing performance. The details of how ECS achieves these performance benefits are highly technical, but it involves leveraging CPU architecture, organizing data in tightly packed ways to benefit from locality in access patterns, and using these access patterns to parallelize as much logic as possible within Hytale. Now, let's talk about ECS in the old version of Hytale. The team knew they wanted to switch to an ECS architecture, even while developing the legacy engine, because it would boost performance and scalability, and align well with their data-driven approach to constructing and configuring game entities and actors. As a result, they developed their own Java implementation and integrated it throughout the legacy server. However, they didn't have an equivalent for the C# client, so their implementation was server-only. This effort involved refactoring existing logic to follow the ECS pattern, while developing new functionality alongside it. They learned many lessons during this time. Building a robust and performance ECS framework from scratch was incredibly challenging and time-consuming. There are countless ECS variations, each with unique benefits and drawbacks, requiring deep technical knowledge to execute well. Java's performance quirks force them to make many concessions and design choices. Despite these challenges, their initial ECS implementation delivered noticeable performance benefits and a new system architecture that embraced data-driven design principles. If done correctly, it would allow modders to easily influence game behavior with almost no technical knowledge. A question that many might be wondering is, why Flex? Well, the team explains to us that when they rebooted the engine, they decided to stick with ECS and extend its use to the client for maximum benefits. Transitioning to C++, they explored other frameworks and chose Flex, created by Sander Mertens, an ECS expert. Flex offers excellent performance, multi-platform capability, and a smart implementation of parallelization and multi-threading. Thanks to its C and C++ API, it's faster than C# or Java implementations and doesn't require us to maintain it, as it receives frequent updates and bug fixes, ensuring stability. Flex also provides advanced features beyond a traditional ECS framework. For instance, it supports relationships to connect entities such as a parent-child relationship or more complex ones like entity A likes entity B. This structure allows us to run specific queries, making it highly flexible. This technical enhancement is beneficial for the progress of Hytale development because it will help the NPCs having the ability to think faster, also reacting to changes within the environment of Orbis, and allow for a much more responsiveness to their surroundings than ever before. To close the month of June off, the Hytale team also released an International Pride Day post, saying, "Wishing everyone a happy International Pride Day. Hytale celebrates and welcomes LGBTQIA+ folk this month and every month." With that, they shared this beautiful Pride-themed drawing to celebrate. As we head into July, the Hytale team has given us a deep dive into their engine transformation with a new blog post. We've explored the magic behind the scenes, focusing on Flex, a cutting-edge entity component system that's revolutionizing Hytale's performance, modding capabilities, and cross-platform potential. By rebooting the engine in C++ and leveraging Flex, the game is set to achieve new heights, making NPCs smarter and more responsive. From the benefits of Flex, including its superior performance and advanced features, to the flexibility it offers for both developers and modders, it's clear that this framework is a game changer for Hytale. As the team continues to refine and innovate, we can expect even more exciting Hytale blog posts in the near future. And that wraps up today's Hytale news video. If you enjoyed this deep dive, make sure to like, subscribe, and hit the bell icon for more updates. Leave a comment on what you would like to see in the next blog post or even a video. This is Ani, signing off. Stay tuned for more Hytale news. Bye-bye.